All right, welcome back. Let's work this chemistry problem together. Remember to follow, like and share with family and friends, and also check us out on our YouTube channel, TM Pro Academy. There you will see full videos of all these series, right? All right, so let's hit the ground running. So here, the first question, this is under chemistry. The first question says, which of the following, this is a JAMB Chemistry question. It's a full paper, right? It's a full paper. So which of the following would support the conclusion that a solid sample is a mixture? All right, so let's see. Now this question is asking a very important information about mixture identification. So how do you identify a mixture? The first thing is that you should know that a pure substance has a sharp melting point. That's number one. Number two is that a mixture shows melting range, and then the correct option here should be that the solid has a melting range of 300 to 375 degrees centigrade. Yes, because this one shows what? A melting range. Okay, now let's look at number two. Number two say the molar of carbon to hydrogen, that is a mole ratio, right, of carbon to hydrogen of volatile liquid compound is 1:2. So the ratio is 1:2, right? And then they say 0.12 gram of the liquid evaporate at XTP and gave 32 centimeters cube of the vapor, right? Then now say the molecular formula of the liquid is what? So we have to find the molecular formula of the liquid. But recall that the question say it made up of what? Carbon and what? Hydrogen. So the ratio, these ratios will be for carbon is to what? Hydrogen. Okay, so let's see. Let's look at the volume or the molar volume at STP. So molar volume at STP is already given as what? 22.4 dm cube, right? Okay, so this the volume is in 32 centimeter, but we have to convert it to dm cube. So in doing that, whenever you are converting from centimeter to dm cube, you have to divide it by what? 1000. So when you divide it by 1000, you're going to be having 0.032. So now it will be in what? dm cube. So same volume with the volume at STP. Now, if you want to calculate the number of moles now, don't mind me, I'm doing it in different places, but please just follow suit, right? So if you want to calculate the moles of vapor, right? Moles of the vapor, you then say the volume given divided by the molar volume, which is 0.032, divided by the molar volume, which is 22.4. Now when you do that, you are going to have 0.00143. This is the number of mole that is involved, right? Now how do you get the molar mass, right? Molar mass is equals to what? The mass divided by the number of moles, right? Divided by the moles. So, and that will give you what? The mass is given as 0.12, and then the moles, we calculated it to be 0.00143. So when you divide these values together, you are going to have 84, approximately 84. Now if you have 84, now let's look at the compound that we are working with, carbon and hydrogen. Now the ratio is 1:2. That means carbon is 1 and hydrogen is what? 2, right? So it is CH2. Now this is the formula that we have, but then this formula is just the empirical formula. So if you add the values together, carbon is 12 plus hydrogen 2, that gives you what? 14. So if you want to know their actual ratio, you have to divide this molar mass by this what? Empirical what? Formula mass. So that will give you the actual ratio now. Actual ratio will then be what? Now say 84 divided by what? 14, and that gives you what? 6. So the ratio of this compound will now be CH and multiply by 6 here. So if you multiply through by 6, you have C6H12. This is the formula, the molecular formula they are asking you. So the answer is what? D. Yes. Yeah, so the answer is D. Okay, so let's go to question number 3. Let's look at question number 3. So let's put our JAMB series back. JAMB series, right? Our JAMB series. Yep. Okay, JAMB series. All right, so let's see number 3. Number 3 is talking about it can be used from the vapor of pressure curves above that. If you look at these curves, you will discover that higher boiling point must be equal to the lower vapor pressure. So if this is the temperature, it shows the boiling point, and this is the vapor pressure, right? So what this will actually mean is that, let's see, liquid has the highest boiling point. No, liquid has the highest boiling point. This is repeated. This must be typographical error. Then liquid 3 has the highest boiling point. So if we look at it critically, we see that liquid 3 has the highest boiling point. You can see that the temperature is higher here. So this is liquid 3, liquid 2, liquid 1. So our answer is C, right? Without even wasting much time. Let's look at number 4. Number 4 says 20 centimeters cube of a solution containing 0.53 grams of anhydrous sodium carbonate in 100 centimeters cube requires what? 25 centimeters cube of sulfuric acid for complete neutralization. So this is a neutralization reaction. So when base react with acid, they form salt and water, right? Now the concentration of the acid solution in moles per dm cube is what? So we have to find the concentration of the acid solution. But then we know that we can calculate the number of moles. They say 100 centimeters cube require 25 centimeters cube of acid. So for the base, we have the volume to be 100 centimeters cube, for the acid to be 25. Okay, so let's start from the base now. Let's start from the base. For sodium carbonate, now the number of moles, right, would then be equals to, in 100 centimeters cube, in this 100 centimeters cube will then be what? 0.53, because mole is mole divided mass all over what? Molar mass. So the molar mass of sodium carbonate using these values given, well, I think that's a very common value. So it gives you 106, right? 106 is a very common value. So we'll have 0.05. We have 0.005. Then number of moles in 20 centimeters cube. That's now talking about the acid now. So we have to do 0.05 times 20 divided by 100. So that will give us what? 0.001, right? Mole. Now let's look at the reaction. If sodium carbonate reacts with tetrazosulfuric acid, how would it look like? So let's see. H2SO4 plus Na2CO3. So when they react, we are going to be having what? Sodium sulfate plus water plus carbon 4 oxide. So let's see if it's balanced. This sodium is 2, this is correct. This one is 3, this is 7. So let's see, this is 4, 5, 6, 7. Okay, so it's balanced. Now if you look at the ratio of the acid and the base is 1:1, meaning this number of moles that we have gotten in 20 centimeters cube is also that of the acid as well, right? So if you want to look for the acid concentration now, so the acid concentration will then be what? The number of moles divided by what? This 0.025 that we had. So it will give you 0.04. So this is the number of the whole concentration of acid that we are looking for, 0.04. So if you look at it very well, your answer is what? B. All right, let's check question number 5. Yes, so oxygen gas, and for carbon monoxide to undergo complete combustion, it must form carbon 4 oxide, right? So to balance this equation now, let's see. To balance this, if we put half of this, let's see. Yes, so it's balanced now. This is 2 and this is 1. With this half here, it gives 2 as well, so it's balanced. Now if you look at it critically, they say 10 centimeters cube of carbon monoxide must need what? Will need what? If you look at it critically, it will just need 5 centimeters cube of what? Oxygen, because this is half. To get of oxygen, you just say half of it because of their ratio, so 1/2 times 10, that gives you 5, right? Okay, so now let's see, for this we have 5 centimeters cube of oxygen. Now let's see for the reaction of what? Hydrogen gas. Now reaction of hydrogen gas with oxygen will give us what? Water, right? Water. So if you balance the equation, it looks like this. So if you look at it now, hydrogen has 15 centimeters cube. So what will it need? It will need 7.5 centimeters cube of oxygen, right? Okay, so the total oxygen volume that we'll be needing now will be 5 plus 7.5, and that gives you what? 12.5 centimeters cube. So let's see, do we have 12.5? Yeah, 12.5, option B. Perfect. Now let's go to number 6. Number 6 says, what is the partial pressure of hydrogen? Let me wipe off this so that I can have space to calculate other stuff, right? Okay, so this question says that what is the partial pressure of hydrogen gas collected over water at standard atmospheric pressure and 25 degrees centigrade if the saturation vapor pressure of water is 23 millimeter mercury at that temperature? Okay, so this one now, you just, is a very short question. Just get the standard pressure and subtract this 23 from it, so you have 737. We don't need to even waste time on this one. This one is very easy. Okay, let's see number 7. Number 7, the atomic radius lithium, sodium, potassium are 1:33, right? And 1.54 amp and 1.96 amp respectively, right? Okay, so let's see, which of the following explain this gradation in atomic radius? So if you look at it very well, you just arrange them based on the way they increase, right? This atomic value, right? The way they increase. So we have 1.33, 1.54 and 1.56. So how can we arrange them? The number of electrons shell increases from what? From lithium to sodium to potassium, right? So that's how perfect it is. So let's look at what fits into this. The number of electron shell, increases from, let's see, the number of electron shell increases from lithium, this is supposed to be sodium, there is an error, to potassium. So the answer is C. All right, let's see number 8. Number 8, let me wipe this before. Okay, number 8 say, which of the curve in the above graph illustrates behavior of an ideal gas? Oh, this one too is very, very straightforward. Ideal gas follows Bohr's law perfectly. The curve labeled Y represents ideal gas behavior. So that's it, right? So the answer is Y. Ideal gas behavior will just go straight. All right. So let's see number 9. Yes, we're going to be running this thing up to 10, right? Because of time. To take too much time. Now, element X and Y have electronic configuration of 1s2, 2s2, 2p4, and 1s2, 2s2, 2p6, 3s2, 3p1 respectively. When they combine, the formula of the compound form is what? This one is just straightforward. Just look at their combining powers, right? The first value here, this one, the first one here is oxygen, and the second one here, or let's not represent it as a gas so that we don't get ourselves confused. This one is oxygen, and then the second one, let's see, one outside, this is 4, 10, 13. Yes, 13 is aluminum, right? Yes, so the moment they react, it will be like this, O3, right? So we just look for anything with 2 and 3, 2 and 3. But if the first element X is oxygen, so X will be here, and the second one Y is aluminum will be here, so it will be Y2X3. So we have D, right? Yeah. Okay, number 10, the last but not the least, the atomic number of cesium is 55 and its atomic mass is 133. The nucleus of cesium atom therefore contains what? This one is very straightforward as well. Just say 133 minus 55. What are we going to have? 78. Now this 78, you now look at it. What is the atomic number? The atomic number is 55, right? It's 55 already. Look at it here. So if the atomic number is 55 and the the neutron number is 78, so we just look for 55, 78. Yes, 55, 78. That's B. Boom. That's our answer. Proton 55, neutron 78. Yes, this brings us to the end of this series. If you are happy, I want you to lock it down in the comments section. I'm going to see you in the next one. Take care of yourself and have a very wonderful practice. I love you and I wish you the very best in your exam. Remember to subscribe, remember to like, remember to share. See you in the next series. Bye.